All right, let's dive right into this explainer and look at the architects of darkness themselves, black holes. I mean, it's a topic that sounds like pure science fiction, right? But as we're going to see, it is a very real, very powerful part of our cosmos. Get ready, because we're about to completely shift your perspective on how gravity, space, and time actually work.
Here's our quick roadmap for today. 1. The cosmic monster. 2. Tracing the shadows. 3. Anatomy of darkness. 4. The black hole family. And finally, 5. Evidence and wonder.
Starting off with Section 1, the cosmic monster. So what exactly are we dealing with here? Well, simply put, a black hole is an inescapable trap of gravity. And the stakes here are absolute. The gravitational pull in this region warps space-time so severely that absolutely nothing, not even light, can achieve escape velocity. It is literally a true one-way ticket.
Now, these aren't just, random pockets of empty space out there. They're actually the dramatic remnants of massive stars. Step 1, you have this massive star. Then, step 2, when that star reaches the end of its life, it doesn't just quietly fade away. Nope, it undergoes a catastrophic collapse under its own immense gravity. It pulls all its mass inward, crushing it down into a single point. Which brings us to step 3. A black hole is officially formed.
Moving right along to Section 2, Tracing the Shadows. Figuring this out was basically a scientific relay race spanning nearly 2 centuries. Way back in 1783, John Michel first proposed this wild idea of a dark star, with gravity so strong that light just couldn't leave it. But it wasn't really until 1915 when Albert Einstein published general relativity that the scientific framework truly supported the possibility. Right after that, Karl Schwarzschild took Einstein's work and found the actual mathematical solution to prove they could exist. And finally, jump to 1967, and John Archibald Wheeler gives the phenomenon the incredibly catchy term we use today, the black hole.
Now for Section 3, Anatomy of Darkness. Now, even though the black hole itself is completely dark, the environment immediately surrounding it is incredibly complex and active. We're talking about a structure with a distinct outer boundary, a chaotic swirling center, a super dense core, and intense energy shooting right out from the top and bottom.
Let's quickly unpack how this monster actually feeds, because it all comes down to these key components. First, you've got the event horizon. That is your ultimate point of no return. Cross that, and you're never coming back. Then, right at the very center lies the singularity, an infinitely dense point where all that collapsed star matter is just crushed together. Surrounding the outside is the accretion disk, which is this massive swirling disk of superheated matter just waiting to fall in. And those poles? Those are the jets, incredibly powerful beams of energy shooting outwards.
Which brings us to Section 4, the black hole family. Because, not all black holes are created equal. We essentially have 4 main types here. We've got stellar black holes, born directly from collapsed stars, stepping up to intermediate, and finally, the colossal, supermassive black holes that literally anchor entire galaxies. Now, those 3, they are proven to exist. However, the last category, primordial black holes, these tiny ones thought to be formed right at the beginning of the universe, well, those remain purely theoretical for now.
And that leads us to our final section, Section 5, Evidence and Wonder.
Because look, these aren't just abstract mathematical equations sitting on a chalkboard anymore. They're out there, right now. Take Sagittarius A star and M87 star, for example. These are real-world instances of supermassive black holes. Sagittarius A star is incredibly special to us because, well, it's the monstrous anchor sitting right at the center of our very own Milky Way galaxy, holding our entire celestial neighborhood together. Meanwhile, M87 star is another famous, insanely massive example located in a distant galaxy.
And then we hit 2019. This is the monumental year humanity finally achieved the impossible. For centuries, black holes were just math, just theories or indirect observations of gravity acting strangely. But in 2019, scientists successfully released the very first actual image of a black hole. We finally actually photographed the unphotographable.
So, to wrap our heads around everything we've explored in this explainer today, here is a rapid-fire summary of 5 amazing facts. 1. They form from the dramatic collapse of massive stars. 2. Their gravity is so absolute that not even light can escape. 3. At their very core lies an infinitely dense singularity. 4. Tiny primordial versions from the dawn of time might theoretically exist out there. And 5. In 2019, we finally got our very first picture of one.
I'll leave you staring into the cosmos with this one final thought. We've gone from Jean Michel's theoretical dark stars in the 1700s to actually photographing the event horizon of a supermassive giant. But if the fastest thing in the universe is trapped forever within that boundary, we have to wonder, what else is hiding in the dark, waiting to be discovered? What other secrets are locked away in that singularity? I'm hoping this explainer sparked your curiosity to look up at the night sky and want to learn even more.